Alright, what's up everybody? Thanks for checking out my video. This is our first one that we're going to have at least for this semester. Some other ones that I did post on Haiku were made a while ago. So this I'll actually use my own method of conversions. Should make more sense than maybe the other ones. But all we're looking at is stoichiometry, mole-to-mole conversions, aka s'mores. There's nothing different. So what I want to look at today, this will take probably about 5 minutes, not even. All we need to do in order to do stoichiometry is a balanced equation. So unlike the previous unit with just moles where we just had individual substances, in this case we have an entire reaction. Now you will never have to balance something like this because it's kind of crazy, but I like doing this equation, or this balanced equation, because there are many different substances, and you'll see that it doesn't matter how complex the balanced equation is, stoichiometry is just like making s'mores. Nothing different. So again, I got different colors for each substance. You're gonna realize that we're not even gonna use all of them. It doesn't matter. So if you look at this, you're like, oh man, there's so much stuff there I don't understand. Doesn't matter. Don't worry about it. So what I first want to look at is one example of how to do some simple mole-to-mole conversions. So for our first little example, we're only going to do 2. Let's say that 28.3 moles of water are produced in this reaction. So obviously water up here. How many moles of chlorine gas are also created? So right away, we're only using 2 substances. There's going to be the water. There's going to be the chlorine. That's it. So we're not using these other things. All right. Some people in the past are like, well, what do I do about the MnCl2? What do I do with the HCl? Nothing. Don't worry about them. All right. To you, they are just kind of useless. So honestly, you can just like cover them up. They don't matter. All right. All of a sudden, oh, 6 things turns into 2. Hooray. So very similar to what we did in class, all we're doing is a mole-to-mole conversion. Don't let the mole unit confuse you. It's just a unit, all right? It's not scary. So let's say we have 28.3 moles of water. As in every single conversion ever, we always start with our given quantity. It's not 8. Oh God, no. Not 8. That is used in the balanced equation. Your given measurement is 28.3 moles of water. So what we're going to do is jot down 28.3 moles of H2O. Show your units. A lot of people like to get lazy at this point, just do 28.3. 28.3 moles of H2O. You'll thank me later. Because again, we need to know how to convert our moles of water into moles of chlorine. All right. Oh, look, there's our relationship. So according to the ratio, or to the reaction, every time, I'll get rid of this. So every time you create 8 moles of water, according to the reaction, 5 moles of chlorine are also made. They are related. Just like for s'mores, if you use 1 marshmallow, you also use, we said 3 chocolate pieces. Same idea. 8 water moles, 5 chlorine moles. So that's what we do here. So down here, we're going to do, let's see, 8 moles of H2O on the bottom. And since we're using chlorine gas, chlorine's up here, not 10. No, 5. 5 is your coefficient. That's what we're going to use. All right, we're not doubling anything. Don't be multiplying 5 by 2. You'll never see me do that in class, so never do that. So 5 moles of Cl2. Cool. Yet again, why do the moles of water go on the bottom? To cancel out moles of water. And again, that is why I show my units, so I know what the heck I'm doing. If you don't show units, people get confused and they put the 5 on the bottom or the 8 on top, or they use 16 because they don't know what's going on. Show the units. It does not take a long time. So in our case, we take 28.3 moles of water times 5 divided by 8. And we should get an answer of roughly 17.7 moles of Cl2. That is your answer. Cool. And again, you can check your units. How many moles of chlorine gas are also created? Oh, look, moles of chlorine gas. So you know it's correct because the units are there. So you don't have to pretty much ask and say, hey, is this correct? You can look and go, okay, moles of water cancel because there's 8 waters there, 5 Cl2s there, everything works. Cool. That's as easy as it gets. But I want to look at another example because sometimes it can be a little weird. By weird, I just mean there's an extra word in there that you don't need to worry about. So let's take a look at this guy. Again, same balanced equation, doesn't matter. Let's say we have 0.217 moles of HCl, that's hydrochloric acid. This guy over here reacts with excess KMnO4. How many moles of potassium chloride would be produced? Oh no, excess. Excess. So people get confused with the word excess, KMnO4. It means nothing. Cross it out. If you ever see excess something, cross it out. It doesn't matter. Again, that's like making s'mores and saying that you have 12 marshmallows, excess graham crackers, excess chocolate pieces. The excess doesn't matter. You just have a lot. It means you have extra, too many. In this case, it doesn't matter. Now it's just like normal. Moles of HCl, how many moles of potassium chloride would be produced? Potassium chloride is that guy. Cool. All right. And it's the same as usual. So we just start with our given quantity. We got 0.217. We're going to do moles of HCl. Again, using different colors because I think colors are useful. All right, moles of HCl are given. How many moles of potassium chloride would be produced? Again, don't worry about this other stuff. You're just worrying about HCl and KCl. I've had some people in the past try to use all the numbers. Oh, don't. Just 2. All right, so according to this, 16 HCl moles are needed to react to produce 2 moles of KCl. So that's what we're going to do here. That's all we're using. We're not using all of them. We're not using molar masses. I'm not using the 6.02 number. Later, yes, but not today. All right. And again, we know those numbers because of the 16 and the 2. Don't be like changing any numbers up here. Don't be using 8 or 5. Like I said earlier, it's just a very easy game of hide and seek. Oh, look, where's the KCl? Oh, there it is, 216 of the acids. Moles of HCl cancel out. So I know I'm correct because I'm looking for moles of potassium chloride. There it is, moles of KCl. Sweet. Do the math. 0.217 times 2 divided by 16. Should get around, 0.0271 moles of KCl. Give it a unit, give it a substance. And that is it. Cool. That's kind of as simple as it gets. It doesn't get any more complicated than that with just mole-to-mole ratios or mole-to-mole conversions. Eventually we will get into some other stuff dealing with grams, but for this, you need to know how to do this. This is the center of everything that we're doing the next couple weeks. Sweet, that's it.